let's jump right into this explainer and demystify the AI system design interview. Today, we're tackling a real-world case study straight from the trenches, designing a customer support agent. If you've ever stressed about surviving the hot seat when an interviewer asks you to architect a production-ready AI system, well, you are definitely in the right place. We're going to break down the exact strategies, frameworks, and trade-offs you absolutely have to articulate to ace this round. Now, here is the absolute core truth of this entire interview round. AI system design is just machine learning system design, right? We aren't inventing some completely new engineering discipline here. The fundamentals haven't changed one bit. You still start from requirements and metrics, and you still pick the cheapest thing that actually clears the bar. We're simply designing around one core component that just happens to be non-deterministic. Keeping that single fact in your head is going to ground your entire architecture. So, because the model doesn't return the exact same thing every time, the stakes of the interview completely shift. The interviewer isn't just grading a diagram on a whiteboard, and they certainly aren't just testing your vocabulary. Knowing what a vector database is, well, that's not going to save you. They want to see you navigate ambiguity. They want to hear you evaluate trade-offs out loud and anticipate failure modes long before a single prompt is even written. Basically, they want to know, do you actually know how the system breaks? To survive that hot seat, we need a structured roadmap. So here is our exact playbook. We're going to cover 1. Scoping before you architect. 2. The 5-layer design spine. 3. Building the support agent. 4. Guardrails and the flywheel. And finally 5. Scaling and security follow-ups. Let's kick things off with section 1. Scoping before you architect. You know, the most common way candidates fail right out of the gate is by walking into the room and immediately drawing architectural boxes. Don't do that. Instead, use the problem-first framework. First, pin down the user and their pain. Let's say our Tier 1 agents are swamped with 60 tickets a shift, and 70% of those are just repetitive questions. Second, the outcome. We want to deflect that 70% to an automated agent. Third, narrow the AI intervention until it actually hurts. It should only retrieve an answer from the help center and immediately escalate everything else. And finally, define the system and safety. We know we need evaluation gates and human handoffs. Setting these 4 pillars proves you're building for actual business value, not just for fun. Moving right along to section 2, the 5-layer design spine. With our problem fully scoped, we need a mental model strong enough to hang any AI use case on. We're going to build this from the bottom up, starting right here with layer 1, the model. This is simply the engine, and it's the single non-deterministic piece of our whole system. You just pick a model that clears the bar for the task, but keep in mind the vast majority of your engineering effort actually won't be spent here. Stacked right on top of that is layer 2, the wrapping layer. And this, my friends, is where most of our architectural design actually lives. This is the heavy lifting architecture you wrap around that raw model to make it truly useful. Next up is layer 3, our evals and guardrails. Now, because layer 1 is non-deterministic, we have to completely change how we think about testing. We must pull evaluation from being this final gate at the very end of a project right into the absolute center of our design. This is exactly how you catch the model getting quietly worse over time. Above that, we've got layer 4. This represents the production and operations required to actually run the thing. We're talking about your serving, your scale, making sure you have robust observability, tracing, and, crucially, a concrete rollback plan for when things inevitably go sideways. And finally, layer 5, optimization. This layer handles the fancy stuff like caching, model routing, and multi-agent orchestration. But here is the secret, and honestly, a massive red flag if you get this wrong in an interview. You only reach for layer 5 after the core system actually works. All right, let's get into section 3, building the support agents. Now, let's apply this framework directly to our specific case study. For a support agent, we are going to spend the bulk of our time in that heavy lifting zone, layer 2. To build an agent that actually works, one that doesn't just confidently hallucinate a completely fake refund policy, you absolutely have to master this rule of 3. Knowledge, tools, and memory. Knowledge is what the system retrieves. Tools are the actions it can actually take on the user's behalf. And memory is what it retains across the entire conversation. When you're designing that knowledge retrieval pipeline, you have to weigh your trade-offs carefully and loudly. Moving from a basic keyword search to a vector store means choosing the right index. Something like an HNSW index is going to give you incredibly fast, high recall search, but it comes at the cost of much higher memory. If memory is tight, well, you might pivot to IFV, noting to the interviewer that it's lighter but requires really careful tuning. Knowing exactly when to pull these levers, that is what separates a good design from a truly great one. Next, Section 4, Guardrails and the Flywheel. Because our core model is non-deterministic, we have to tackle the elephant in the room: safety. You must sharply contrast your online guardrails against your offline flywheel. Online guardrails act as your fast, real-time circuit breakers. Like if the model outputs an ungrounded answer, bam, the guardrail trips instantly, blocking the response. On the flip side, your offline flywheel runs in batches. This is where you track overall containment rates and monitor things like hallucination drift over weeks. Conflating these two jobs in an interview is a fatal design mistake. And that brings us to Section 5, Scaling and Security Follow-ups. All right, so you've built a solid architecture and established your guardrails. But in the real world, systems get stress-tested. The interviewer looks at you and says, now handle 10x the traffic. So where does it break first, and what's your very first move to prevent the whole system from collapsing? Here's the secret. At scale, the data and retrieval layer almost always breaks first, well ahead of the model itself. So your first move is upgrading retrieval to a hybrid dense plus BM25 approach, probably using that HNS-W index. Next, you pull some levers from layer 5. Cache the stable prompt prefixes, implement semantic caching, and route those simple queries to a smaller, faster model. Finally, down in layer 4, you scale horizontally behind a queue and use connection pulling so that a sudden traffic spike degrades gracefully. Always state the bottleneck first and then the fix. Then comes the security trap. The interviewer presents a scenario where a malicious user hides instructions in a help document. You are now dealing with a lethal trifecta: untrusted content, private data, and the system's ability to act via prompt injection. So how on earth do you stop this? You shut this down instantly by treating all retrieved help articles strictly as untrusted data. They are data to cite, never executable instructions to follow. You absolutely must enforce a strict separation between the mechanism that answers and the mechanism that acts, utilizing least privileged tool scopes. And crucially, human approval remains the ultimate hard circuit breaker for any high-impact actions. Even if an injection somehow slips past your input guardrails, a human reviews the drafted action before it executes, neutralizing the threat entirely. And just like that, you've successfully navigated the ambiguity of AI system design. You've scoped the problem, applied the 5-layer spine, centered your evaluation, and safely scaled a customer support agent. By mastering this single, repeatable framework, you're no longer just memorizing whiteboard architectures. You're practicing sound, scalable engineering judgment. So, with this incredibly powerful toolkit now in your hands, what complex AI system are you going to architect next?